Hello, hello everyone, and welcome. Hope you're having a great day. This is a pretty fun class that we have going on. Happy Thursday. Happy Thursday. Let me introduce myself a little bit. My name is Alex Cooper. I teach the computer classes for the Columbia County Library in Evans, Georgia. So hello, Georgia. Hello, Evans. Also, I teach for the Harlem Library, which is the Facebook page that we're on right now. So hello, Grovetown, and hello, Harlem. Very glad that you're here this morning. And hello, Mac. How are you? Welcome. This is a bit of a fun class, and I teach the computer classes for those libraries. And right now, of course, we're staying home, staying safe and everything. And so we're doing all our classes virtually and stuff. So this is one of our fun classes, a project class. Okay. So let me kind of go through and talk about some of the stuff we got going on. Big thing is definitely if you have any questions, post questions into the chat. This is a live recorded, so you'll be able to watch it later and can share it with friends or family later. And the biggest question I usually ask is, how can I help? Okay. So any questions? Have you tried to get started in Raspberry Pi projects before? Are you more interested in the Raspberry Pi? I'll have a little bit of information about that, but I also have some previous videos on there that says Introduction to Raspberry Pi as well. And we'll do some more Introduction to Raspberry Pi classes in the future live as well too. So Tuesday we did a photography, printing, and virtual scrapbooking class. That was kind of like part 4 of the classes we have going on. And of course now we've kind of moved into October, which we'll talk about that in a second. Yesterday we did cutting the cable, basics of cord cutting. That video is still up and available, talking about all the neat things with antennas and Roku's and the new Chromecast that's coming out and the Peacock app that's coming out. We talk about all that kind of stuff on there. And yesterday afternoon we did creating videos and editing basics as well. Okay. So this is kind of our last month. Can you believe today is October 1st? We teach classes on Tuesday, Wednesdays, and Thursdays. We'll have the new schedule coming out for next week and the rest of the month. And this afternoon, one of the classes we'll be teaching is Library Resources and Apps Live, including the new Libby audiobooks and ebooks app. Okay, so come join me for that. We'll kind of do an overview of that. All the rest of these classes are still up and available here on our YouTube channel. The photography classes, the chess classes, other Raspberry Pi projects, the Microsoft Word, Excel, and PowerPoint as well. Just a little side note, our libraries are open with limited services and hours. Curbside holds pickup is available. You can go to gchrl.org for details or call the library with questions Monday through Friday, 10 a.m. to 5 p.m. Don't forget to like us on Facebook and subscribe to our YouTube channel. We're doing a subscribe. Anyway, we're trying to get 100 subscribers to our YouTube channel so we can get a customized YouTube address. Okay, or search YouTube for GCHRL videos and it should pop right up. Okay. All right, so let's go ahead and let's flip back here, and I'll come back too. So welcome. So we're going to be doing some of our project here, and our main project of the day is, so I'm going to actually have a separate camera here pop up in just a second. Let me see. There we go. Yay. So let me see if I can move it around a little bit here. Straighten it up. It may shake a little bit. I will tell you that. It does happen. But here's our Raspberry Pi parts here. Of course, I got my mouse here, so if you wonder what that is, there we go. So let's go ahead and talk about what we're going to be doing. And the project we're going to be working on. They call it a breathing LED. Okay. And the way this kind of became about, and I'll actually post this at the end of class, the way this actually came about was because I did get a project box. And this project box is from the company Free Novi. And I purchased this, and it's called the FreeNovi RFID Starter Kit. Okay, if you can see that. So I already had the Raspberry Pi, wanted to do some new projects, and the really cool part about this is it actually comes with new all kinds of little gadgets and stuff in here. Here's your RFD motors and everything. And one of the projects does move the camera around a little bit. Okay, but here's our connections and everything. Of course, we're going to talk about the GPIO pins set up here. I'm going to go ahead and post the introduction pamphlet that I do when we do the big introductions class. We do our big physical computing with Raspberry Pi class. So I'll kind of point to that a little bit. Hello, hello, welcome, welcome. All right, so there's my big handout. I just posted that into the chat, I guess you'd say, of course. So this is one of the projects that actually comes with the FreeNovi, and like I said, this is actually the RFID starter kit. Okay, so let's go ahead and let's oh, I wanted to upload the handout too, so let me do that real quick so we're all on the same page. Let me ask you, what projects have you done with the Raspberry Pi? Kind of post that into the chat. And I'm going to okay, hang on. Let me see one thing here. Aha, that's where that is. And it looks like the my connection to YouTube may be cutting in and out, so I'm sorry about that. Why, I don't know. Okay, go ahead and upload it. Okay, we'll have to do that later because it's thinking about it too much. Okay. Okay, so we can go ahead and take our buttons off here. Back in our little box. Let's talk about our project. So these classes are just kind of something of, I wanted to be able to create some more projects that we can do for our classes at the library. And of course I had a box of a whole bunch of really neat things here. Oh, all kinds of neat things, LED screens and everything. So that's kind of how this came about. So let's go ahead and I'm going to plug in our Raspberry Pi here, and then we'll get it up on the screen. I'm actually using the VNC software to connect. So we have to get our Raspberry Pi minute to connect there. There we go. So now we actually have our Raspberry Pi connection as well. Okay. And of course, we have our keyboard here when we need it. All right. All right. So let's go ahead and let's read about our project. So this is actually called, they call it the breathing LED. Okay. Let's kind of read through it. Chapter 4, Analog and PWM. In previous chapters, we learned that a push button switch has two states, pressed on and released off, and an LED has a light on and off state. Is there a middle or intermediate state? We will next learn how to create an intermediate output state to achieve a partially bright dim LED. First, let us learn how to control the brightness of an LED. And I will zoom in a little bit more here. We describe this project as a breathing light. This means that LED is off. Will then turn on gradually and then gradually turn off like breathing. Okay, so how do we control the brightness of an LED to create a breathing light? We will use PWM to achieve this goal. Okay, so it says all we need is our LED. There's our LED right there. And then we need a 220 resistor, which is what we have right there. Now I'm going to triple check to make sure. I actually have a little schematic here. So let me 100% make sure that that is 220. Okay, well, I know I have a little thing over here, more of them, so let me grab that real quick. Anyway, I believe that that's what it is. Let me make sure. Where did my other thing go? Okay, so let's see. Well, I believe that's it. Okay, so basically we have our LED, we have our jump wires. Of course, we have our Raspberry Pi is all ready. So let's go ahead and get started. Component knowledge, so we're just going to read a little bit of here. Now, I don't understand all of this, so of course I'm reading along with you, trying to learn something new. Component knowledge, analog and digital. An analog signal is a continuous signal in both time and value. On the contrary, a digital signal or discriminant time signal is a time series consisting of sequence of quantities. Most signals in life are analog signals. A familiar example of an analog signal will be how the temperature throughout the day is continuously changing and could not suddenly change instantaneously from 0 to 10 Celsius. However, digital signals can simultaneously change in value. This change is expressed in numbers as 1 to 0, the basis of binary code. Their difference can more easily be seen when compared when graphed as below. Okay, so we have our digital, we have our analog. I remember a while back it was a whole big thing about basically the difference between like MP3 or digital music and I guess the recorded analogically from recording artists and how that was missing out on the little bits of the curve of the wave. Okay, so let's see here. Let's go ahead down to our code section. It's talking about the off and on cycle. And I do know that the code actually explains a little bit more. So let's talk about our connections here. So it looks like we're going to be connecting to GPIO 18. Now, anytime you do the thing here, and I actually have, where's that board? I believe I had the board in the other room, but usually what I do is I actually have a nice little schematic, but it is listed there. So it looks like it's 1, 2, let me see, where is it here? 1, 2, 3. It's 3 on the right. Okay, so three on the right is GPIO 18, and of course we can use ground anywhere. They're showing the extension there, and the other ground is, where's my other ground on there? Let's see. Well, I think I'll go to my thing because that's a little bit different than what I usually work with. No, that's about the resistor. Okay, hang on, I got something loading. It's going to think about it for a while. Okay, it doesn't show enough. Okay, that's not what I want then. Okay, come on. Thank you. It's loading forever. All right, so I'm going to go back to my normal. I don't know why that's a little bit different. But if we just zoom in, because usually in class what we do is I actually have a little topper here. There you go. Top right. Okay. And that's a little different than our graph there, isn't it? Because it actually shows, okay, is that what's going on here? Okay, so it's 1, 2, 3, 3 on the left is our ground. And then we have GPIO 18, 1, 2, 3, 4, 5, 6. So 6 on the right, 4, 6 on the right is our ground. No, is a GPIO 18. Okay. All right, so let's go ahead back. I guess this, oh, this is the schematic for here. If you use the ribbon, which I'm not using the ribbon right now, I'll just connect directly to it. Okay, code. This project uses the PWM output from the GPIO 18 pin to make the pulse widely gradually increase from 0 to 100. To make the LED glow brighter than dimmer. Okay, so it's breathing. Gives all the information there. LED first, observe the project results, and then learn about the code in detail. If you have any concerns, we can contact Freenovi. Okay, so the file we're actually going to be opening is called breathingled.py. Open that real quick. All right, so we have our file open, and here is our file. Let's keep talking here. Note the LED is connected to the I/O port called GPIO 18. The LED is defined as pin 12 and set to output mode according to corresponding chart for pin designation. Then create a PWM instant and set the PWM frequency to 1000 gigahertz and initial duty cycle to 0. Okay, so first let's set up our Alright, so let's go ahead and set up our LED. Of course, we have to do short leg to long leg, and we're going to test it out to make sure it's working. we'll go back to our handout. If we actually go in, so that's Gpro 18, that was number 6. That's ground. So we're going to go ahead and try test it out first. Got to make sure with our breadboard it kind of lines up this way, long leg to short leg. Okay. And then we'll connect up 3 volts of power. And our LED light should come on. Okay, so already having to figure out what I've done wrong. 3 volts. There's the, now number 3 over there is ground. Okay, so whoops, did I not have it on the right one? Let's see. Oh, let me go back and remind myself and make sure I'm doing this right. Okay, long leg, short leg. Oh, okay. This was backwards. There we go. There we go. Yay. Okay, so we know that our LED light is working. And we'll change it from the power to number 6. Our GPIO pin there. Now, we'll go ahead and make sure our whole section is working properly. We'll do our switch on the LED and switch the LED off. So let's go ahead and I'm going to switch over to VLC here. So there's our little Raspberry Pi. Okay. And we're going to use the MU. This is the new operating system. It's not Raspbian anymore. It's Raspberry Pi OS. Okay. It should be pretty big on the screen, I hope. There you go. That little everybody can see the screen at the same time. There we go. Okay, so let's do our code. And I got my keyboard. Okay, from GPIO 0. Whoop. Can I do? How do I do that? Told you it still is a little bit new to me. Let's see. Okay. Alright, so let's see if it'll turn the LED on. Oh, and we are on, if I move that mouse out of the way. We're actually on 18. Whoop. Move the dot on. Okay, now it's going to make me name it. Name it temp. Or how about light on? I'm going to use the other keyboard because that seemed a little slow. Okay, so we have our LED on. Okay, so now we want to turn it off. We'll run it again. We'll tell it to stop and then run it again. And there it goes. So we are connected to the GPIO 18 and now we know it. Okay, so let's go ahead back to our code. And I'm not sure how to zoom in. Zoom in. that seems really small. I don't want that to be too small for y'all. There we go. Okay, so I know I have to do it. Okay, so go ahead. I'm going to go and hit save and I'm going to name it. No, that's funny. Okay, so let's just try doing a new file here. Okay, now it should ask me to save it. Okay, we'll call it breathing. All right, so let's go ahead. So import. Import time from the time library. Okay, so we're defining the LED pin. Okay. Nope, that was not capitalized. Let's see. Yep. All right, let me check our code so far. Let's see, import RPI, GPIO, let's see, time, LED pin 12, define setup, global P, GPIO, GPIO setup, GPIO board, physical, use physical GPIO numbering, GPIO setup. Let's see. LED out. Set LED pin to output mode. Output LED GPIO 0. Make LED pin output low level to turn off. Okay. All right. So let's keep going. So P equals GPIO dot PWM open parentheses LED PIN comma 500. Okay. Set PWM frequency to 500 hertz. Let's see. P CART start close. Set initial duty cycle to 0. Okay, so now find loop. Okay, so we are on a loop. So we have our while true loop. Make sure the true is capital. Jane, that's awesome. Yay. Okay. All right, so while true, let me open this a little further. Don't know if I need to stop. Okay, so where was I? Define while true for DC and range circle 0, comma 1. Okay, to make the LED brighter. Okay, so is this the cycle that's going to go through? Okay. And it made a sub. So P change YouTube duty CYCLE. Oh, what did I do? Oh, that's backwards. All right, P, duty cycle, DC, make DC value as the duty cycle, okay. So we're setting up time, sleep, wow, okay. Let's see, and then, all right, so there we go. Time, sleep, it's 1 second. For DC and range 100, comma, -1, comma, -1. Interesting. So I guess those are different settings. So we have our 3 cycles, I guess. Let's see. All right. Check that. Define loop while true for DC and range. It's 1. Remember, first attempt is always fail. So change duty cycle Time sleep. Time sleep. Oh, that needed a period. Time sleep. Let's see, for DC, range makes the LED darker. Okay, so this is minus. So this is brighter, 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 darker, darker, darker. Okay. All right, now, this is a sub, so why didn't it do the sub? Oh, because I don't have, whoop, did not put the colon in. Now, there we go, okay. Let's see, for DC in range, let's see, so P, change duty, change duty cycle, DC, okay, time, dot sleep, let's see, 0.01, and make sure that's right. So for DC, range 1, 2, minus, minus, P change duty, time sleep, and then time dot sleep 1 second. Okay. So we're almost done with our code. Let me switch over to our, because we have that going on. There we go. So we can actually see it. How about that? Okay, so our time sleep, let's see, 26. Okay, so define, destroy, T, stop, stop PWM, GPIO, clean, clean up. Okay, releases all the GPIO. Okay. All right. If. Okay. Program is start. Interesting. Okay. Okay. There's our. I guess it's just going to tell us that because it's just printing on the screen. Set up try loop. If blank equals. Okay, that I'm definitely not familiar with. So hopefully I'm doing this right. But we are learning something new. That actually looks like 2, but I don't want to do 1 right now. Okay. I don't even know what that is. Is it just the equals? I guess so. Underscore main. Underscore. And colon. Okay. Okay, well, it did indent it properly. So print program starting. Okay. Set up. Try. Loop. Accept. And that's the normal keyboard. Control C will end the program. Okay, let me check. Well, let me do that and we'll check our code. Destroy. Okay, so see if name, main, print, program is starting, setup, try, loop. Uh-oh. So this needs to be, well, it automatically put it in an indentation like that, but it shows it outside, so I'm going to do it that way. Okay, need to move this one in then too. We will see. In worst case scenario, I'll just flat out open this file over here. Okay, so let's go ahead and look back at our code. Okay, so the LED is connected to the I/O port, GPIO18. The LED is defined as pin 12 and set to output mode according to the corresponding chart for pin designation. Let's see. 12. Now that I'm not familiar with, so would that actually move the pin around in some way? I'll have to check that. Then create a PWM instant and set the PWM frequency to 1000 Hertz and the initial duty cycle to 0, so it should be dim and then get brighter. There are 2 for loops used to control the breathing LED and the next endless while loop. The first loop outputs a power signal to the LED pin PWM for 0% to 100%, and the second loop outputs a power signal to the LED PWM for 100 to 0%. Now in class, I could see us actually starting out with making it bright and then putting the code in to make it dim again, just so we're kind of following along. Okay, so the relative functions of the PWM are described. P, GPIO, PWM, frequency and channel. Let's see, create a PWM instance for the duty cycle. Change frequency where the frequency is. Duty cycle. Let's see for more information. Okay, so let's go ahead and let's see. Whoop. Let's go ahead and do save, and we will hit run and see if it works. But remember, first attempt is always fail. First attempt in learning is fail. Oh, there we go. Didn't like something already. Okay, so I didn't understand exactly what this is. So let me see. Is that a double underline? Name is not defined. Okay. Okay, so tell it to stop. I'm not familiar with that. Let's see. Aha. Okay, so that is a double underline. So that must be a double underline as well, because that's what it looks like. Okay, now let's do save and run. Program starting. Whoop, look, it's doing it. Oh, you can't see. I got to turn the camera on, don't I? There you go. Ah, look, it's working. It's working. Cool. Look at that. So it's in a loop. So I could actually see with students taking this. Like I said, I'm trying to, work this out to do some things so we do with students and stuff. Let's see. Program start, homebrew LED, runtime warning, this channel is already in use. Use GPIO, set warnings, false to disable warning. Let me see, continue anyway. Look, it's working. Okay, so let's talk about what we actually know from previous classes, okay? So the one thing that we definitely know is that where it says time sleep is 1 second, okay? So if I do stop, we did get an error message, which I'm not 100% sure what that means. I'll have to look into that, but let's look at our time sleep, okay? So why don't how do I save it as a new file though? Can I not save it as a backup file and mess with this one? Let's see. Okay, I think that would work. Okay, so if I call this, let's see. I'll call it backup for now. Okay, so we'll close that, or just go ahead and open up the normal one. So we do have a backup. I'll close the backup. So now we can mess around with this one. Okay, so, and of course, I did want to know if our keyboard did work. So we do run, LED should come on. Sorry, I moved it. And if I do the Control C, there you go. It did make it stop. Okay. All right, so let's do stop. Now let's kind of mess with our code. So a big one with me is if you've been in previous classes that I've done, and I'll actually move this over here now. If you've seen previous classes that I've done, you'll know that I'm a big one about, okay, we did a code, now let's mess around with the code so it makes us learn it a little bit better and understand it, okay? So let's go ahead and look at our time sleep. So I do know from our previous classes that we've had with our LEDs and stuff, time sleep where it says 1 here, okay? You might mess around with this in a second, see what that does. Time sleep actually means 1 second within. So I believe, and we're going to find this out together, I believe the 1 second means it pauses for a second and then it starts again, or this might be within the same time frame of 1 second. We'll actually have to see. So let's just change this one. Let's change that one to 2 and see what happens. Okay, so that actually means that when it gets bright, it's actually going to pause. So let's do it half a second, which is 0.5. Let's doing it a little faster, isn't it? All right. So let's change this one to 0.5 and see what happens. Does it feel like it's doing it faster? I think so too. It definitely still feels faster than the 1 second. So here's the original. All right. How about we'll do 0.2. So that'd be a quarter. There you go. All right, so now that we learned that that is what that controls, of course, let's change it to 5 and see what happens. There you go. So basically what it's doing is when it reaches the pinnacle, it was supposed to basically stay bright for a second because it has cycled through. Okay, I really like that this code already has the while loop on it. I've done a few codes with like class and stuff, and then they have to keep restarting it, and then I'm like, okay, let's talk about a loop, and then we add a loop, and then the interesting part about that is then it seems like it's a little bit easier to use, I guess you could say, because then you turn it on and it just does it over and over. Okay, so let's do stop. Now that we know that basically this is bringing the pinnacle of the brightness, okay, so I'm actually going to change it back to a second on both. So this is about the pinnacle. So this is the brightest it'll be, and then this is basically off. How long did you want it to be, off for? So let's go ahead and let's mess with our other time sleep, and then we'll kind of learn a little bit more about the rest of our cycle here. So let's go ahead and I believe what was the other thing that I had? Okay, so if we go back and it talks about, let's do that. Okay, so right now it looks like the time sleep is at 0.01. So it's really, really, really fast, okay? What if we actually change that to, instead of 0.0, why don't we change that 0.01, how about 0.2? So that'll be much slower, okay? Let's see. Ooh. There you go. 2. You can actually see it like stepping up, can't you? Step, step, step. And it reaches it right there. Hang on, we're not there yet. Right there, I think. Right there. Here you go. So I'm gonna stop it. I'm gonna change this to 0.2 as well. Oh, not 0.22. You're running. Okay, so it's a very gradual, it's like a morning sunrise almost. And then it'll dim a lot slower as well. It takes a while. And off. On. All right. And then it's good. It's bright. And then there it goes. It's turning off. That's cool. Okay. All right. So what did we learn about our code? Well, we've learned about time sleep, which we kind of already knew about that a little bit. So what if we wanted to do it faster? So they had 0, 1 here, didn't they? Let's add another 0 and see what that's like. Okay. So it should very quickly turn on and then very quickly turn off. Oh, well, yeah. So let's see what that's like. Whoosh. There you go. That almost looks like a, no, you can tell that that's not just on and off, but you can definitely tell that that's a gradual still, can't we? And that's just messing around with our time sleep a little bit. Okay. Does feel like it needs a sound effect, doesn't it? Okay, so now I actually wanted to see if we could since we have that going on, I'm going to switch it back to the original too, just so that we're keeping our code kind of the same. So if we go back to our code area, and I'll turn my thing off for now. I hope the camera's helping so you can actually physically, of course, see what's going on with our little project here. So if we go back over here, it talks about the physical GPIO number. The LED pin is set for output. Made LED output low level to turn off. You see set WM frequency to 500. Okay, start. So let's see what else can we do with our code. I was actually hoping to have a 2 LED system. I'm trying to figure out exactly how to do that, because we'd actually have to set up another pin, which would be like LED, and I guess we just give it another name. LED pin 12. Go through there and let's see. Let me make sure I can do that. Range. Define setup LD pin number 12. Pin. Let's see. GPIOP equals 500. Define loop. Range. Change cycle. Okay. Define, destroy, clean up. Okay. So we still got a little bit of time, so I'm actually going to see if we can add another LED. So let me get turn my little camera on here, and let's see what we can do. Okay. And we got blue. How about red? And let's see. Oop. it's 220 if I remember. Oh, let me get this out here. Whoop. Sorry. Shaky shake. There, 220. All right, so your long leg, short leg. Kind of neat if I can get them to kind of blink near each other, I guess. Maybe I need to move everything down a little bit. Now we'll go ahead and check it. And let me pull up my chart. I have real issues sometimes. I don't know why, but it's like the mouse has completely disappeared for some reason. Okay, so let's check our wires. And the other ground is, let's see, got 3 on the right. And the other ground, there's one on the bottom left if I want to do that. And I could do 21. That would be good, I think. So the bottom, I'm going to do that. The bottom left is ground. And let's plug it up to our 3v3 volts, and we should have our LED come on. Yay! Okay, and then we'll plug it into GPIO pin 21, because that'll just make it easier. Okay, so, and the mouse has disappeared again. Okay, and then it's back. Okay, so let's go ahead and let's kind of read through our code here. So this is saying LED pin equals 12. Let's see, so GPIO pin LED 12. I'm not really sure because I haven't had the experience. It looks like they're kind of setting the board to a different numbers to global. I'm going to look that up real quick. Let's see, Raspberry Pi set mode. Let's see, board. wondering how I can explain the difference between the two mode states above. It looks like online can't find anything. Tells library which pin numbering system you're going to use. Board signifies using the physical pin numbers on the Raspberry Pi connector. BCM signifies the Broadcom SoC channel designation. One word of warning, the BCM channels move around a little between versions 1 and 2 on the board. The board numbering system stays working between board revisions. The board number system stays working. Okay. So let's see. That was 7. Okay, so let's look at this. Telling you, we're learning together today. Okay, how to set up board and GPIO numbering schemes. And RPI GPIO 0, you can use either pin number board or the Broadcom GPIO numbering BCM, but you can only use one system in each program. Okay, I habitually use a GPIO numbers, but neither way is wrong. Both have advantages and disadvantages. If you use pin numbers, you don't have to bother around revision checking. Yes, the GPIO 0 takes care of that for you. Still need to be aware of which pins you can and can't use, though, since some are power and ground. Okay, if you use GPIO numbers, your scripts will make better sense. If you use breadboard, which also use GPIO numbering, if you want to use the P5 header. Okay, it's important to pick one that makes sense to you and use it. Also important to always be aware that other systems keep it working else. So at the top of every script, after importing the GPIO 0 module, you'll set the GPIO numbering system. Okay, so they've set it to board. GPIO set mode equals board. How to set up GPIO port as input. Okay, hang on, you're switching on me. What was our topic here? Okay. Okay, hold on. Okay. They is actually two use GPIO pin a little, but also have known that two different numbering systems can be used. Okay, if you take a look at the main GPIO header, as prior, you'll see that there are 26 pins. Top left, we took the photo called pin 1. There, the right, pin 2, so next row, blah, blah, blah. Next, so it's 26. But pins have names too. The slightly confusing part is that each pin is also a name according to what it does. Some of them have alternative functions, but GPIO doesn't currently control those, so if you ignore them for now, the best way to see which pin number does what is with the diagram. Okay, so, okay, I see. So the reason that LED pin doesn't say GPIO 18 like I have done in previous classes is because they're doing this, they've set this pin board setting. Okay, so if I want to put it on the bottom one, I don't even see 21 on there. So why does this schematic have ground and then GP21? Okay, is that confusing? Of course it's confusing. Okay, so the red ones, of course, are power. Why is that not GPIO 21? So, okay, so we're learning something new here. The rest can all be used GPIO ports, but does not have the function. So basically, this code sets it up so that instead of saying this, which is what I'm kind of used to, And it says this numbering system, okay? So the board system. So Gpro is set to board, okay? How to set up a Gpro pin as an input. Let's see, use the following code. Change port or pin to number Gpro port to pin you want to use. I'm going to use BC Gpro pin 20, so it becomes Gpro pin 25, okay? Okay, well, let's look at our code. So we have set mode, he's put it in board mode. Gpro pin out, Gpro pin output. Let's see. Set up Gpro pin 25. Gpro pin, oh, it references this, so that means it's 12, which is 18 when we look at that schematic, okay? So set up LED pin out GPIO output. Let's see, so GPIOW start 500 loop. Okay, well, let's do the first thing that we need to do. Let's see if we can actually figure out and change it from using this LED to using this LED, and that'll be our first start. Okay. So if we look at our chart here, let's pretend, so right now it's on 12, meaning GPIO 18. I've only ever named the names, even though I knew they weren't in order, which can be confusing, and why that says 7 and not, but maybe that doesn't matter, because now we're going to switch it to where it says 26. So maybe if I go here and I change this from 12 to 26 and then hit run, it should do our red LED. Let's see if that works. If not, we'll get an error message and we'll try again. Okay, guess we're not going to get an error message, we're going to get a nothing message. All right, let's look and see where else. So, of course, that was 12. See if anything else here in the code said 12 on it. Clean up the program, destroy the cycle. Let's see, while true. And of course, if I switch it back to 12, I did move the thing, so let's do a test just in case. Okay, good. So that one is working. We'll stop it. But when we did, so that says 12, which is GPIO pin 18. Hold on, let's see. Where do I actually have it? It's actually on the 6th row. 1, 2, 3, 4, 5, 6. Yep. So 12 and 26. So why didn't 26 work? And I actually do not see a GPIO pin 21 on there. So let's just move it down one, and then we'll rename it 24 and see what happens then. Okay. So if I change this to 24, okay. Let's go and tell that to stop. Let's see. Okay. So I'm going to go ahead and do our code like we did before. Oh, did I save that time? There we go. All right. let's just go back to our, oh, that's right, it didn't do that. Okay, so I have to retype that. So give me 1 minute. Go back to our testing our light. Okay. Whoop. So from, sorry, DPIOCERO, import LED, LED equals capital LED, and it's actually set for 17 right now, but we're actually going to change it to, I'm going to put it back what I originally had was to 26. I'm sure this is all something very simple that somebody's done this for years. They go like, aha. So LED equals LED. Wait. Oh, I already did that. Dot on. Oh, where's close parentheses? Okay. All right, so let's do run. See if our red LED light comes on. No. Okay. If I go and I change it to 18, let's make sure our code's right. Yep, there we go. Oh, now I have to tell it to turn off though. All right. So why didn't that one work? Okay, so if we actually go back to our handout part here, whoop. Oh, 21. What number was I doing? So why did I say 26? Okay. Yay, okay. Was I saying the wrong number? Possibly. Okay, so then we want to turn it off. Okay, so right, and that's on 12, right? No, it's on 18. Duh. Even I'm getting confused. Yay. All right, now I gotta tell them to go turn off though. All right, now that I've confused myself, there we go. Okay, so let's go back, and instead of making that, okay, so that needs to be, okay, so that website had a chart. Okay, so it's saying that's GPIO 7. Now my brain's getting, that's where I got 26 from. Bleh. Okay, so, but my other, bovine, 0.24. button. See, that's a normal one. It says 21 on it. Okay, so So headers have names. So the next row is 3 forks center down to 2 to 5. That's how the pin headers are numbered. Slightly confusing part is that each pin has a name according to what it does. Some of them have alternative functions, but we just currently have setup board and Gpro pin numbering schemes. Important things to pick up one that makes sense, where the other systems can work. So at the top of every script, after importing GPIO mode, okay, set the numbering mode, and that's what this code is done. So let's import that as GPIO, okay. And then we have defined global set mode to board. To board, okay. So this is board, right? Let's see, it's like confusing. Take a look at the, you'll see the pin's top number, photo, call it, right on board. Tell us how the pin heads are numbered. So that's pin heads, but what about the board mode? The board mode, okay. GPIO code. Outputs for, maybe that's not what we have. This is saying 4. Okay, so import GPIO setup mode 25 to GPIO. Setup mode is low. Oh, we don't have the other settings. GPIO, okay. GPIO VMW 500 start loop range cycle test. And then we have our cleanup. So what number in board mode is what we want to know. Okay, I'm gonna do another search real quick. Maybe one that explains it a little bit more. I want to make sure that, because we're using a Raspberry Pi 3 right now. Nope. Okay. So it says board node specifically refers to the pins and the numbers of the board. Okay. BCM mode means that it refers to the pins on the Broadcom SoC channel. Okay, so pi 1, 2, and 3. Wow, okay. So that would be pin, right? So instead of it being 21, they'd be called 40. All right, let's try it. Yep, there you go. All right. Very, very good. So 12 is our first pin. There you go. And 40 is our other pin. Okay. I actually would probably prefer not to have to do it that way, and it to be more, of course, that may, someone probably will say that's the much better way of doing this. I would probably prefer it to be using this method of being able, because this is the pins that I actually do have. Put it on there, GP21. So if I actually did not, set, go back to where we were, sorry. If I actually did not set this mode, which I probably would mess around with this more to figure that one out, how to change that. If I actually did not set that mode, could I just use the normal GPIO basically like I have been in the past? Okay. But there's the red. Let's see. Let's leave it on for a second. All right, so we did pretty good, didn't we? We did learn something new, didn't we? So we're kind of getting close to the end of our project here. Hope you enjoyed that. I think I learned a lot. Hope you got to learn a lot too. We have our breathing code on there. Let me go ahead and see if that did upload so I can post it to our chat. Because, yeah, it did upload. And this was actually from the handout that comes with the free Novi. Well, it's on their website. I guess that's what I should say. But that's the handout I was using for our code. Okay, so we learned a lot, didn't we? I think so. Getting the thing to do the breathing is pretty cool. I actually want to get them both doing it at the same time, but that's something we did figure out, something new about the coding of the board. The GPIO pins can be numbered in a different way, even than we have done in previous classes. So we did learn something new, okay? So I'll go ahead and I'll bring our class to an end and basically thank everybody for coming. Let me tell you about our class that we have coming up this afternoon, and we'll have our new schedule for the month coming out as well. So this afternoon at 2:30, we're going to be doing our free library resources and apps class, including they talk about the new Libby audiobook app that's out because we're switching over from the RB Digital to that. We'll be talking about that at 2:30. And just to let you know, our libraries are open with limited services and hours. Curbside holds pickup is available. You can go to gchrl.org for more details on that. Of course, you can call into the library with questions Monday through Friday, 10 a.m. to 5 p.m. Don't forget to like us on Facebook and subscribe to our YouTube channel. And also remember to hit subscribe because we're trying to reach our 100 subscribers goal so we can get our own personalized YouTube address. If you are trying to find our YouTube channel, the easiest way to do that is to search YouTube for GCHRL videos, and it should pull it right up. So thank you for coming. I hope you enjoyed class, learned something new. And I will see you guys next time. Have a great day. Have a great afternoon. And have a great October because it's October 1st. The spooky season is here. And stay safe. Bye-bye.